Welcome to solverfy.
All right, question 83 is a qualitative question. Um, the first part says, A, when you exercise vigorously, you sweat. How does this help cool your body? So we're looking at the relationship between sweating. For A, we're looking at the relationship between sweating and the cooling of your body. So when you sweat, the sweat starts as a liquid and it vaporizes to a gas, right? The sweat starts to evaporate off of you. And in doing so, this process of going from a liquid to a gas is an endothermic process, meaning it requires energy, it requires heat to break those intermolecular forces that hold the sweat, which is a mixture of water and salts and proteins and other components. In order to break all those intermolecular forces and separate them out as a gas, that requires energy. And the liquid is going to want to evaporate because it's trying to hit the vapor pressure. But assuming you're not sweating in a closed box, you're not going to hit vapor pressure equal to atmospheric pressure because you're in the atmosphere. You're continuously, the gases are continuously going off and therefore not in an enclosed container. You're going to continue to sweat and sweat, and you're going to continue, this is going to continue to change into a gas and vaporize because you're not, again, in a closed container where the vapor pressure can build up to atmospheric pressure. So it's going to continue to vaporize continuously. And that process is an endothermic process. And where is it getting the heat from? It's getting the heat from an energy for this endothermic process. It's getting it from your body. So it's taking energy or heat from your body to change your sweat from a liquid to a gas, thus cooling your body because it's removing the heat. So that is why sweating is a cooling process. Part B says a flask of water is connected to a vacuum pump. A few moments after the pump is turned on, the water begins to boil. After a few minutes, the water begins to freeze. Explain why these processes occur. Okay, so first you are starting off with liquid water, and it's changing into a gas because it's going through the boiling process. Right, so it's boiling here. Why is it boiling? Well, let's remember what boiling is. Boiling occurs when the vapor pressure is equal to the atmospheric pressure, or the pressure, in this case, inside the container, the pressure inside your container. Well, it says you have attached a vacuum and you are pulling out the air, thus you are decreasing the pressure inside the container. So as you decrease that pressure and the water has its vapor pressure at this specific temperature, it's not going to be long until the pressure inside has decreased to that vapor pressure, and therefore your substance starts to boil. So now it's boiling, but boiling takes energy. Boiling is an endothermic process. Just same thing up here. You're going from a liquid to a gas. This is an endothermic process. So where is it getting the energy from? Well, it's taking some of the energy from the water itself, from its surroundings, but that includes the water. And so the temperature of the water is going to start to drop because it's taking the energy, the heat from the water to go through this process of boiling, of changing from a liquid to a gas, of breaking those intermolecular forces. So breaking those intermolecular forces requires energy. That energy is coming from the heat in the water. Therefore, the temperature of the water drops. And eventually, the temperature of the water is going to drop to the freezing point, and your water, freezing point, and your water will freeze, taking all the energy, kinetic energy from the molecules. The molecules are going to no longer be able to break those intermolecular forces that allow them to move around. They're going to form more permanent intermolecular forces and stick together, thereby freezing and forming a solid.